What's happening, dogs? Mr. Allen here with some mathematical magic going on in this video here. Actually, it's just going to be normal math, but it's going to be dope. Write the quadratic function in standard form with the given zeros. I only see 1 0 here. I only see 1 0 here in part B. That's weird. Oh, wait. Let's think about that. You know quadratic formula? Where it's got like the opposite of b plus or minus the square root of b squared minus 4ac all over 2a? Remember that one? Okay. I said plus or minus the square root of that stuff, right? We have plus the square root of 3. So we also need x equals 2 minus the square root of 3. There's my other 0. And now I can write this function here. I'm going to start with it in factored form, where I'm going to have x minus one of the zeros, so minus, and you really need another set of parentheses here. Okay, so I'll do that. And we're going to have our 2 plus root 3 in those parentheses. I'm going to do the same with my other one. We're going to have x minus, and then I have 2 minus root 3. Okay, so there we go. Excellent. So just like if you had, like, say, 5 as one of my zeros, I'd have x minus 5 as my factor. If I had negative 8 as one of my zeros, I'd have x minus negative 8 or x plus 8 as my factor. It's pretty easy to write it when they're just normal numbers, right? We're dealing with something like this, a little bit trickier with the radicals. And be very careful here with these parentheses. You can actually get lucky, and if you don't have the parentheses here, the algebra does end up, the mistakes work each other out, right? But that's just a lucky chance here with this style problem. So don't get in that habit of being like, it doesn't matter, right? Your teacher may mark you off for that if you do not have your proper groupings and things like that, okay? So from here, I'm going to have x minus 2 minus root 3. That's my first set of parentheses. And then x minus 2 plus root 3. That's my second set. And I'm going to throw in some more parentheses now, because you might be looking at this thing and see, oh, they both have x minus 2. That's cool. I wonder if that's significant. It's super significant for the rest of this problem here if you want to make your life a little bit easier. So I now have x minus 2 minus root 3, and I have the x minus 2 plus root 3. I have something minus and plus the same something, okay? So what I'm getting at here is, remember problems where we have like, let's do a x plus 4 and x minus 4. What happens when I FOIL this out or distribute out? I get x squared, right? Then I get minus 4x and plus 4x and minus 16. The minus 4x and the plus 4x from the outer and the inner will always cancel each other out when it's in this form. And that's what I actually have happening up here. I have this exact same thing going on in a very ugly looking way. I have the same first part, same second part, same second part, 1 negative, 1 positive, 1 negative, 1 positive. Okay? So I can actually use what I know about this, where the middle guys are going to cancel, and just ignore that part of the distribution process. So this problem's a lot shorter and a lot more manageable, if you will. So I'm going to have x minus 2 times x minus 2. X minus 2, x minus 2, or you can write it as x minus 2 squared, but then people tend to screw that one up and distribute. So don't do that. All right. Here I'd have root 3 times x minus 2, and here I'd have negative root 3 times x minus 2. Those terms will cancel, as we talked about, so I just need to worry about my minus root 3 and my plus root 3 becoming negative root 9, which is 3. So we'll work that out. All right, I got x squared, and then we have negative 2x and negative 2x. That's negative 4x plus 4, and then we have minus 3, and here we are, x squared minus 4x plus 1. Boom, diggity, f of x. There we go. I'm thinking about the, maybe another one. All right, f of x. There we go. Beautiful. It's a terrible f of x. Let me fix that. It's going to bother me. It's going to be bothering me, guys. A little better. All right, let us continue, children. Let's continue on to the next one here. We'll do the same kind of thing here. New example, right? That way, if you're like, hey, man, I think I'm going to try this one on my own right now. I suggest it, dude. Try it on your own. Crush it. I think you'll crush it. Okay, I'm going to use orange on this one, actually. I'm going to use orange. Okay, so same idea here. I know I have to have x equals -3 plus root 7 now on this one, and then we'll work this thing out. Cool? So I'll use g of x for this one since I was itching to use g of x over here. So we get g of x equals, and I'm going to have x minus, go ahead and grab my pink marker here for the parentheses. Whoop. And we have -3 minus root 7. Sorry, that's kind of tiny there. And then I have x minus parentheses. Give myself a little more space this time. All right. And I got -3 plus root 7. Okay, there we go. So let's distribute that negative, shall we? Okay, we shall. We got x plus 3 plus root 7. And we have x plus 3 minus root 7. And once again, we have the same two guys right at the start, which I am going to group to help me with my distribution that I have going on here. Otherwise, you need to like distribute with like 3 terms to 3 terms. It's a lot, okay? So noticing these things here is super helpful in the world of algebra if you can like find little patterns and stuff, okay? So I got x plus 3 times x plus 3. So x plus 3, x plus 3. And then I have root 7. Positive root 7 times negative root 7 is going to be negative square root of 49, which we know is 7, but I'll go ahead and just write it out. So here I've got x squared. Actually, I don't need these parentheses anymore once I FOIL it. Whoop. So we got x squared plus 3x, that's 6x, plus 9 minus 7. So final answer here, g of x this time is equal to x squared plus 6x plus 2. Boom diggity. Boom diggity. So 2 dope problems there, man. There is another way of going about this one here. I prefer this method, and knowing these like little groupings here. It helps with this one, also with imaginary numbers. But I have seen people solve them in different ways, which is totally cool. Up to you how you want to solve it. Maybe I'll make another video on a different way of solving these. But there we go. That's pretty dope. That's awesome. See you guys later.